Let's continue in an example. We will just talk through this example first and then go through the details and formalize the hypothesis testing next. So in the previous example up here, we had this case, the situation where we want to see if the wage of workers is different than 14. And different than means either side, it could be less than or greater than. Normally you probably want to show, in reality you'd probably end up wanting to show that it is less than something, or that it's isn't what it should be. Okay, so let's go back to that example. So this is how you'll start setting things up. Again, we'll go through this briefly, and this is how they suggested you do that example. You suppose you sample 100 construction workers. Your null hypothesis is that the actual mean is $14 per hour. This is an old book, remember. And the alternate hypothesis is that it's different than 14. Okay, so they go through, and suppose you have, you do the sample of 100, and suppose you have a mean of that sample to be 15, and the standard deviation of that sample to be 2. So it's up or down $2. Just seems, reasonable standard deviation. Okay, and then, so this is the test statistic that you will be doing next. So you do x bar minus the accepted, which would be 14, and then s over square root of n. And so it's 15 minus 14, and this calculates to 2 divided by 10. The square root of 100 is 10, which is 0.2. So you basically have 1 divided by 0.2, which ends up being 5. Now right there, that should tell you something, because z is the number of standard deviations away from 0. Well, 5 standard deviations from 0 is way out here. So that means it has to be not 14. I mean, this should tell you something. That's what the test statistic does. That's 5, oops. Just to be clear on the test statistics, that's 5 standard deviations from 0, because you're centering it on the z-score. Okay, so this is an outline. This isn't how we're going to be doing it. The p-value we'll talk about more carefully in the next one, but it's the actual probability of this occurring. So you'll get the value, then you go into the tables and do the calculation. So you can do this calculation, and there isn't a z-score of 5. So if you go to the tables, it stops at 3.49. So you can't even get there. So it's approximately 0. You add it up. Okay, so you add this plus this, and that's essentially 0 probability. So that, remember, a small p-value means it's farther away from the accepted, which would be 14. So in fact, the accepted is wrong in this case. So this implies the actual wage is probably higher than 14 in this case. Okay, so now we want to go through and formalize this concept. Okay, so we formalize this process called hypothesis testing. So this is how it goes. And I'll write out these in detail. This is for large sample hypothesis testing for mean, mu. So mu is the actual mean of the population. So you state the null hypothesis. Once you have that, the null hypothesis is H naught. So you say H naught, and that the actual is equal to the accepted. And you would write a number down right there. So accepted value mu naught, but not necessarily a fact. And what you end up getting, the idea is that researchers want to disprove or uphold by statistic. It doesn't have to be disprove. It could mean you want to uphold it by these statistical tests. Okay, so that's what we will be doing. Okay, so when you're doing these, you have to determine whether it's a one-tailed test or two-tailed test. Okay, and that's a little bit of the pictures were above there. All right, so your alternate hypothesis, we say HA, you have H sub A, so HA, mu is greater than mu naught, the actual is greater than the accepted, or vice versa, or mu is less than mu naught. That's for a one-tailed test. And then your alternate hypothesis for a two-tailed test, mu does not equal mu naught. Okay. So you state that, you got to figure that out based on the information given. Then you calculate your test statistics. This is when you gather your information. You're going to need your X bar, you're going to need S, and your N. So your test statistic is Z equal to, and you say X bar minus mu naught. Remember, you don't know mu necessarily. And then it's S over the square root of N. Okay, and so I wrote a note there. We always estimate sigma with S for large N. When we say large N, we usually mean above 30, and generally the more the better. Okay, so your rejection regions, when we say reject, you're rejecting H naught. You never reject HA. You either accept HA or reject H naught, and I'll tell you that language more. Okay, so one-tailed test, some details to talk through here. This is your alpha. It could be on the left side or right side, but that's a one-tailed test. So this is when we are saying that Z is greater than Z sub alpha, or Z is less than negative Z sub alpha. And that will be down here. The negative cases will be to the, obviously, right, to the left of 0. Over here, we say you divide by 2. It's alpha over 2. And go back here. So this value is your Z sub alpha. So that's your, like, for 5%, that's your 1.96. And we'll go through how to do some of those calculations. And then these values, this is your Z sub alpha over 2. And right here, this is your negative Z sub alpha over 2. That's your two-tailed test. And so you'll construct that. Many of these values will be standardized. You don't have to look them up each time. You'll know when we'll say stuff like you want a your alpha is 0.05, your alpha is 0.01, and those values were pretty much standardized. Okay, so your alpha represents the level of significance. Graphically,
how large or small the rejection region is. So the rejection region, or interval really, are these. So a larger alpha is going to come farther over like this, and it's bigger. A small alpha, you're going to go farther away, and it's the actual probability, like it's this area. So a small one means you went farther away from the mean. Okay. Right. P-value is the actual probability of this occurring. And we'll show that calculation. All right, your conclusions. Oh, let me show you alpha. Let's see. Okay, so here's some more details I had for you. Researchers usually use alpha equal to 0.1. That would be 10%. 0.05 is pretty normal. 0.01, but can go down to 0.001 or even further depending on the situation, which I'll state in a second. So this is 10%. This is 5%. So that'd be like 90%, 95%, 99% chance, right, of it occurring, that type of stuff. I'll erase that. Okay. This is 1%. This is 0.1%. So just in general, the small alphas are more for critical cases, critical things. So this is just your idea in your mind. You keep an idea concept. This is more for medical concepts. Whether that medication is going to cause deaths, for example, you want it to be very small alpha, right? Small probabilities and stuff. These concepts might be more for education. You're not going to hurt someone extremely necessarily for a large, if you make a mistake on saying something works or not, you just, it's not as critical. So you have maybe a larger alpha. Okay, and that depends on all of the case or the situation. Okay, then the conclusions look like this. So this is important, how you conclude. So conclusions, we say reject the null hypothesis, reject H naught, and conclude HA is true. We say accept, you can say it like this, accept or do not reject. That's the softer way of saying it. Do not reject H naught as true. So if you reject the null, that's how you would say it, then your test statistic is in the rejection region. It's here, or on the other side here. And then you reject the null hypothesis. If it isn't, if your test statistic is here, then you do not reject the null hypothesis. Or you can accept it, but a lot of times you just want to say, let's just not reject it. So you're not saying it's true, you're just not rejecting it. So other types of wording you'll hear is you reject the null. Any stat person would know that type. You know exactly what that means. You reject the null. It's that concept. Or you'll say, do not reject the null. So that's like the, I don't know how to say that. That's your
vernacular region for stat people. So how you would say that. Okay, so we will use this type of wording. So this is the wording we use. So I'll just say use this type of wording. So like if we were in class, I would be saying stuff like, well, are you going to reject a null or not? You know, something like that. Can you prove that you're going to reject a null, or are you going to accept a null? Or how would you want to say that? So that's the language that we use, stat people use. Okay, next let's do a specific example from start to finish. It's sitting right here. So write all this down, and then we'll go through it.